Okay, so this is the second part of 2.5's videos. Now, I would really suggest that you hit pause right now so that you can write down the steps that I have. A couple of things about proofs for right now. Most of the proofs that you have will either have the statement or they'll give you the reason. So right now, they're not going to make you do a complete whole proof all on your own blank. Okay, they'll either give you one or the other. But eventually, yes, we are going to be doing proofs where you are given nothing and you have to write it from scratch, where I might tell you the number of steps total. Okay, so go ahead and hit pause on the video right now, write this stuff down so that you have these steps, and then go ahead and hit start it again, and then I'll go through and explain everything. Okay, now that you've gotten through and you've got everything, one of these steps down, it says, what is the value of x? And then justify each step. So it says here, given ray AB bisects angle RAN. Okay, so this ray AB bisects RAN. Now, one of the things we know, if it bisects it, it cuts it into two equal parts. So I know that this angle and this angle are exactly the same measure. Okay, what they want you to do, and this part I added to this because you'll see this as well, is they want you to prove that angle BAN is 75 degrees. Okay, so I've got a little 7-step proof here that I've written down for you. Okay, and if you remember, usually always it says here ray AB bisects angle RAN. Wait, where do we see that before? Well, that's what they gave you. That's to get you started. Okay, so in this case, it's the given. Okay, so step number 1, again, we're going to write down as the given. Okay, so now, as this goes, remember, each step builds on the previous step. So from step 1 to step 2, it says here in step 1 that ray AB bisects angle RAN. Well, then it says in step 2 that angle BAR, this left angle, is congruent to angle BAN, which is the right angle. Wait, how do we know that that's true? Well, we know it's true because in the previous statement it said ray AB bisects the angle. So this is what we call the definition. This is what we call the definition of our angle bisector. Okay, definition of angle bisector. We know that by the definition of an angle bisector. An angle bisector says if a ray bisects it, it cuts it into two equal parts. Okay? All right, so now we went from naming angles in step 2 to all of a sudden now I've got variables and numbers. Well, wait. Angle BAR, that's x. And angle BAN, that's 2x minus 75. All I did here was substitute expressions in for the angles. So this is what we call the substitution property. Okay? Substitution property. I substituted in values. And now, from here, it should look very familiar to what you did here. So from step 3 to step 4, they're asking, okay, what did we do here from 3 to 4? Well, in order to solve this thing, I got to subtract 2x from each side. That's how I got to negative x equals negative 75. So this is the subtraction property. And then how did I go from step 4 to step 5? How did I go from negative x equals negative 75 to x equals 75? Well, what I did was I divided by negative 1 on each side here. So this is the division property. And we now know that x is 75. Okay, so now these last two steps are two steps that are pretty new. You have not seen these ones before. It says here in step 6 that angle BAN is equal to 2 times 75 minus 75. Well, if you notice that up here in the top, we know that angle BAN is 2x minus 75. Well, instead of x, they replaced the x with a 75 that we said before, because we said x was 75. So since they replaced the x with a 75, this is what we call the substitution property again. Yes, it is very possible for you to use multiple steps that are the same in one proof. Okay, so in this case we have two substitutions in this proof, and that's okay. You're going to see that that happens quite a bit. And then the last step here, angle BAN is equal to 75. Well, how do they come up with that? Well, if I take 2 times 75, that's 150. And if I take 150 minus 75, I get 75. Okay, so now look at this. Wait, did the left side change at all? Nope. In this case, what they did is they combined like terms because they multiplied and then they subtracted. So we call this, in this case, combining like terms to simplify. Okay? And you have now completed your first more or less true proof, where I give you a given and something that I want you to prove. One of the things that's common is on that last step is to write down, well, this is what they want me to prove, so I'm going to put the word prove here. That will never happen, by the way. So don't write prove as the very, very last step. Okay, so on your video, you're going to need to hit pause again so that you can write this down. This you do not have in your notes, so you're going to have to write this part down. I've added this example in there, so make sure you do that. Pause the video, write the steps down. Okay, so now that you've paused the video, you got all these steps down, got the picture down and everything, let's go through and let's get this thing filled in. So what I want you to do is I've got you the given. AC is 50 units long. And I want you to prove to me that AB is going to be 31 units long. Okay? So first step, it says AC is equal to 50. Well, I told you that in the given. So again, the first step here is the given. The second step says, if you look at the picture, the second step says AB plus BC is equal to AC. So if I take this part right here, AB, and I add it to this part right here, BC, it's going to equal the whole of AC. Wait, I said some important things there. Part plus part equals whole. What postulate is that? Well, that happens to be the segment addition postulate. That's how I know I can write that. So this is the segment addition postulate. This is part plus part equals whole. That's how I know I can write that. Okay. All right, so now in step 2 to step 3, it went from letters to numbers again. So because it went from letters to numbers, instead of AB, I put in 3x plus 10. Instead of BC, I put in 2x plus 5. And instead of AC, I put in 50. This is what we call the substitution property. Okay? And then from step 3 to step 4. Now again, you're looking at this previous step, 3 to 4, what changed? Well, I went from 3x and 2x to 5x. I went from 10 and 5 to 15. Well, what did I do? I combined my like terms. You notice the right side doesn't change at all. So I'm not adding or subtracting because it didn't happen to both sides. This is combining my like terms. And then from 4 to 5, I subtract 15 from each side. So this is subtraction. This should be second nature to you now as we go through these steps, at least. Steps 3 through 6 should be pretty similar. And then I got to divide by 5 on each side, so this is division. That's the division property. And then I get to step 7. Step 7 says that AB is equal to 3 times 7 plus 10. Well, up here it says that AB is 3x plus 10. Well, what did I do? I replaced the 7 for x. So because I did that, I'm using the substitution property. Okay, and then finally, how did I get 31? You'll notice the left side doesn't change, so it's only happening to one side of the equal sign. I took 3 times 7, got 21, and then I added it to 10. So since it only happened to one side of the equal sign, this is going to be a combine like terms step. Okay, and now you have completed this proof. All right, so you should be able to complete the examples on the last page here of the class kick, and then you should be able to get to work on your homework.